The fourth objective of 2.4, the student will be able to solve applications of polynomial and rational functions. Here's an application of rational functions. A company that manufactures computers has established that, on the average, a new employee can assemble N of T components per day after T days of on-the-job training. N of T, the number of components at time T, is given by this rational function. N of T is 50T all over the quantity T plus 4 for T greater than or equal to 0. Sketch a graph of N, the function, T between 0 and 100, including any vertical or horizontal asymptotes. What does N of T approach as T increases without bound? Of course, we talked about that as an alternative way to say T going to infinity. Well, if you look at the function, you want to get a graph of it. First, you realize that there is no vertical asymptote for T greater than or equal to 0. Okay. You could look at the denominator and see that negative 4 is a 0 of the denominator. Negative 4 is a 0 of the denominator, but negative 4 is not in the domain. Negative 4 is not in the domain of the function. So there is no vertical asymptote, but there will be a horizontal asymptote. Now, of course, the goal here, what are we trying to accomplish? We're trying to sketch a graph. And probably the very first thing you'd want to know if you're trying to sketch a graph, especially of a rational function, is where are those asymptotes? Well, there is a horizontal asymptote, a horizontal line that the curve approaches. And that line is the line y equals 50. N of T, that's the y, right? That's the function. That's the y. Approaches 50. The leading coefficient of 50t divided by the leading coefficient of t plus 4, right? So because the degree of the top, which is 1, is the same as the degree of the bottom, which is 1, the horizontal asymptote, by the rule that we learned, right? Degree of the top is equal to the degree of the bottom. The horizontal asymptote is the line y equals, and then it's the ratio of the lead coefficients, 50 over 1. And so the line y equals 50, that is a horizontal line 50 units above the x-axis, or in this case the t-axis. That's the value that N of T approaches as T increases without bound. That is, as T goes to infinity. So the line y equals 50 is a horizontal asymptote. This will enable us to sketch a graph, or at least it'll get us started, and it will also help us, actually it does answer the question that the other thing we're supposed to do: what does N of T approach as T increases without bound? And we know that's 50 components. So here's our horizontal asymptote. It's a horizontal line 50 units above the t-axis, and the curve approaches that. The curve does include 0, 0, right? I mean, what is n of 0? N of 0 is 50 times 0 over 0 plus 4, which is 0 over 4, which is 0. So 0, 0, when x is 0, when t is 0, n of t is 0. So it goes through the origin and some other points and approaches the line n of t equals 50. And it does include some other points on there. You could find n of 1. You could find n of 50. And you'd have to substitute 50 for t in both places to get some points. And you can get other points that are on the curve. Maybe the easiest one would be 6. Okay, so suppose you had t equal to 6. T equal to 6. Okay, then it's 50 times 6 over 6 plus 4, which is 300 over 10. Okay, this is n of t. N of t. 300 over 10, which is 30. So the point 630 will be on the graph. So the point 630, as well as any number of other points that you could include if you wanted to. And so our main concern is the horizontal asymptote, because with this we know that the answer is 50 components. Okay, we don't really expect workers, no matter how much training they've had, to be able to produce any more than 50 components.